Hi, I'm Jeremy Werner. I'm the Senior Vice President and General Manager of the Core Data Center Business Unit here at Micron. I have the great pleasure of hosting my friend and longtime mentor, Thad Omura, the Chief Business Officer at Astera Labs. Welcome, Thad.
Thank you, Jeremy. It's a pleasure to be here. I'm looking forward to this conversation.
So, Astera Labs is an incredible company. It generated a lot of press last year with a stellar IPO. But some people maybe are not yet familiar with what Astera does. So tell us a little bit about what is Astera Labs.
Astera Labs is a company born in the AI generation. It really was just started in 2017.
Wow.
And what's unique about it is it was founded on a mission to deliver the best AI connectivity. And the founders back in 2017, they were thinking, gosh, connectivity is going to evolve from your common host to endpoint type of connection, especially when AI starts to get big. And what's going to happen at that time, is where they were thinking was when things go multi-processing, it's not just about the bandwidth and the latency that needs to improve for all connectivity. But now what becomes so much more important is the reliability, the flexibility, and how can you make this all scale to an incredible amount of compute processing power where the applications are going to depend so much on that connectivity. And so what we decided to do, Astera Labs, was really to focus on one of the first key bottlenecks, which was GPU connectivity out to the rest of the system. And the company started first with PCI Express retimers, which extended the reach of PCI Express both in the system. Now we do it over cabling and out of the system. Quickly, the company decided to expand to Ethernet connectivity for retiming. And also, we now started to expand to CXL and expand memory connectivity. Back in October last year, we launched our first PCI Express switching solutions, our Smart Fabric switches. And this was really a critical moment for the company because now not only did we provide the extended reach types of solutions, extended memory, but now we're providing fabric solutions for both scale up and scale out. And what we do is really underpin it all with a software-defined architecture. We put software on top of all this to make it highly programmable. This is our Cosmos software stack. And you put that all together and you have a pretty incredible intelligent connectivity platform.
Wow. So 8 years. 8 years?
7 years. We'll go with 7.
7 years. Astera is a company that moves fast. CXL, retimers, connectivity, switches, Ethernet connectivity solutions, really grown super fast. Your first retimer was Gen 5?
Well, actually, we introduced PCI Express Gen 4, PCI Express 4 solutions, but the real volume really took over at PCIe 5.
And now, the big news that we announced together, we've been working together on a lot of interoperability to bring new products to market, testing together. And we were the first companies to demonstrate end-to-end PCIe Gen6 traffic all the way through your fabric and into the SSD. We've also been working a lot on very high performance CXL interoperability using your CXL controller. So share a little bit about why these activities are important for the industry.
Yeah. So a company like Astera Labs, we're as a connectivity company, we always sit in between chips, right? 2 chips. And so proving interoperability and the connectivity early is so critical. We have really found that being first to market with the connectivity technology is so important because what it does is it allows vendors who provide endpoints or the latest CPUs or GPUs to come early and provide a level of interoperability so that as those systems and solutions get designed into actual platforms, they already work and it's faster time to market. So what we've been able to do with Micron most recently is be able to get to this end-to-end PCIe 6 connectivity with your SSD. And this has just been phenomenal because it just outlines the incredible throughput you can now get from solid state storage to, the industry-leading GPUs and other network devices and compute devices as they emerge to market.
Yeah, and we see PCIe Gen6 now coming into the most advanced AI systems. And what you talked about, with customers having to rely on the work that we do, it's so critical because you look at the way that our customers operate, and they're totally dependent on us helping them hit their schedules, and they're moving at light speed, right?
Yeah.
It's not easy, and if they had to figure out all these challenges that we figure out when they get into their development phase, then good luck hitting their very aggressive schedules.
That's right.
So PCIe Gen 6, AI, tell the audience a little bit, what is happening in PCIe Gen 6 in AI architectures? How is that going to be deployed?
Well, PCIe is evolving, and as we go from PCIe 5 to 6, obviously the throughputs are double the rate. And it's that increase.
Obvious for us.
Obvious for us and for the audience.
And the
you guys
audience
should all
knows.
know that if you're
Every
watching
number doubles. Every number doubles.
So what's so important about that, especially in AI, is it allows the GPUs to ingest or transfer data amongst all of these really expensive processing units and keep them fed. Keep the GPU utilized at the highest possible rate. And as things move on to PCIe 6, that bandwidth, that throughput is now there. Now, if you take a look at the latest AI platforms, there's basically two categories that we look at the connectivity. The first one is this idea of scale-out connectivity. And in that type of environment for AI platforms, what PCIe does is it provides the connectivity from the GPU out to either the Ethernet or InfiniBand networked fabric.
Okay.
And the whole goal of that is you can connect a bunch of these AI server platforms together, and you can distribute the workload amongst all of these different servers so that you can then all, kind of operate on one larger big problem through distribution
So
of the
that's
workload.
scale out. That's like 100,000 servers in a data center training the next greatest LLM.
That's absolutely right.
Okay.
So that's, training is a great example of why you would need to scale out the number of servers, PCIe being the on-ramp into the actual GPU, how to get that data in and out for the processing. There's another application that's referred to as scale up.
Okay.
And we actually see a lot of customers utilizing PCI Express for scale-up applications as well. They also utilize customized versions of PCI Express to scale up their GPUs or their XPUs, AI accelerators. And in that case, the use case is a little bit different. What you're trying to do is get all those AI accelerators to work on the same workload at the same time. Okay? That's where having ultra low latency, things like, big words like memory semantics are super important so that the latency amongst the each of the GPUs as they're communicating with each other remains as low as possible so you get the highest level of processing performance. This is critical now, especially as inference applications are moving to reasoning and multi-pass processing.
Right.
That processing element is highly dependent on the connectivity to be super low latency. We also see a lot of other things in that area for scale up. We use PCI Express, but we're seeing things emerge like Ultra Accelerator Link. We know NVIDIA has been out there with NVLink, their own proprietary solution, and now trying to make that a little bit more open as they start an ecosystem around that technology. Okay. So yeah, a lot of things happening in both scale out and scale up.
So a lot of opportunity for Fabric today and in the future.
Absolutely. We see the Fabric opportunity, the connectivity opportunity just continues to grow by leaps and bounds in AI as the workloads expand, more token generation, and folks want faster response from these inference applications.
So how do storage and memory fit into the fabric picture?
Yeah. Wow, storage and memory is so critical to these AI workloads, whether you're talking about training or inference. And the idea is really, there's a lot of different use cases. I'll just cover a couple. But, on these training workloads, the workloads sometimes, or periodically need to be checkpointed because sometimes for whatever reason, something goes down, a GPU goes offline, they need to reload all the data and restart again. And when that's happening, you're wasting time. So in a training scenario, both the memory and the additional storage in the AI fabric is so critical because what you want to do is have the fastest possible access to these devices so that waiting time when you're reloading or you're re-checkpointing or what have you is minimal. And the same thing happens with inference because inference is growing by leaps and bounds now with all this additional processing requirements, multi-pass, having access to more memory space, more storage space to be able to load in the data quicker is what's going to impact the user experience dramatically. So PCIe 6, as we're working on together, what a critical element to make all of this operate at a much faster pace and improve the application user experience.
Awesome. As we went through a lot of the interoperability work, we had to solve problems at multiple different layers of the stack, right?
Yeah.
Talk about that.
Yeah. So connectivity in terms of driving improving interoperability happens at a bunch of different levels, right? You can think about, can two chips identify and talk to each other like they can identify each other's signaling? That's like, can you hear I'm making some noise as we're talking, right? So you can hear me, right? So we can establish, okay, we've got signal connectivity. But can you understand what I'm saying? You know what I'm saying? Can you hear me, right? That type of listening and understanding the language or understanding the protocol is that interoperability at the protocol level. And one of the things I'm proud about our interoperability work together is we didn't just stop at that kind of signal connectivity, can we just identify each other? We went all the way to the protocol level. And what's pretty cool is we were able to prove with a NVIDIA Blackwell GPU, state-of-the-art in PCIe 6 mode, that we could end-to-end from the GPU all the way through our PCI Express switch, through our PCIe retimer in PCIe 6 mode, both of them, and your SSD as an endpoint in PCIe 6 mode, is be able to talk amongst all those chips at the protocol level. We were able to use NVIDIA's GPU Direct Storage Protocol in order to process and transmit all of that data to and from between the GPU and the SSD. And that's just, when we present that to our customers, like we've done all of that interoperability work, their eyes light up. They're like, wow, that's incredible. You can do that at this stage of PCIe 6. And having that done early, wow, it really gives them confidence to design the solutions in.
And 27 gigabytes per second.
Hey, 27 gigabytes per second. That's a lot of bandwidth for an SSD. And obviously, the interesting part about that is you want to gang up more of them because people want even more bandwidth to the GPUs.
Right.
And we think that is a critical element that's just going to keep the demand for more bandwidth and more throughput is just going to continue on as these AI applications
It's
evolve.
amazing. Just 4x4 gets you over 100 gigabyte per second.
Wow.
Right?
Incredible.
And so next generation GPUs have a lot of access to a lot of data.
That's right. So these PCIe 6 GPUs, as they emerge, it's fantastic that now we've got all the infrastructure in place that bandwidth is not a bottleneck to storage now, right? We've got the switching capacity, the retiming capacities, and now the SSD endpoints to make all of that happen.
I'm sure the XPU guys will suck up all that bandwidth
Absolutely.
pretty quickly,
yes.
and we'll be on to something new before we know it.
Well, as you know, the connectivity technology doesn't stand still. So, our intent is to be at the forefront of all of that technology. And I think you can expect not only us, but we're excited to work with you as the technology evolves and increases in performance.
Absolutely. It wasn't easy getting to that stage. You talked about making the PHY and the protocol work, that we ran into challenges on signal integrity on the protocol. It's not like we just plugged it together and it worked, although it happened pretty quickly.
Fast.
Yeah,
pretty
it did.
Fast, yeah.
So what were some of the tricks? How do you design your systems to be able to get around all the challenges during bring up and interoperability and to resolve those challenges so quickly for customers?
Yeah. Well, all of that starts long before the chips arrive, okay? And it's really this thoughtful approach that Astera takes to designing the products, and we talk about being purpose-built specifically for AI. So I'm going to start with the switching solutions. One of the key things that we've done is we've made the switch very purpose-built for AI. We constructed the switch so it's got full line rate peer-to-peer between any and all ports at all times. That's the first thing that you got to do. The next thing, what you really want to be able to get through all these challenges and have fast bring up is to be able to have the telemetry and the diagnostics built into the devices. So if there's a bottleneck within the switch or there's a bottleneck, because of the retimer connection, you can immediately pinpoint it. You know exactly where that is, where to go debug. And then your firmware team, your apps team, they can jump right in and fix those problems. So yeah, there's always a tremendous number of issues as you try to prove connectivity early in the cycle, but having the right tools in place, having the baseline architecture that facilitates line rate, all of those things are absolutely critical in delivering in what we were able to prove to the market.
I think it sounds easy, but the reality is this is something that actually takes a lot of effort in engineering, not just to have the flexibility. I mean, we kind of ran into a similar thing bringing up our Gen 6 SSD. But we had to tape out the chip before PCIe Gen 6 standard was actually frozen, right? So we're integrating IP. We need to build in a degree of flexibility. But then once the chip comes back and you're testing in the real world and you have variation and different things that you're connecting to, different PCB challenges, chip-to-chip variation, temperature, humidity, whatever it is that impacts you, that debug, that visibility is key for the engineers to be able to tune the system, write the firmware, take advantage of the flexibility, and bring the product to market.
Flexibility is the name of the game, and having a software-defined architecture is just fundamental at this stage of the game. And what's a little known fact, we actually have more firmware engineers at Astera Labs than we do any other engineering discipline, because that firmware is so critical in getting the device to run, but also being adaptable. Once you get into a system, our Cosmos software allows us to make those changes very quickly, adapt into different environments, and ultimately it's to get the customer to market as soon as possible so they start buying chips.
Right.
That's
well, we have a lot of customers who want to get to market fast. So what advice would you give customers who want to implement a PCIe Gen 6 product?
Well, the first thing is to start early. Okay, I mean, even despite all the interoperability testing that we have and all the goodness of showing everything works, every system is a little unique and they're all very complex now. So obviously having experts at our companies review designs early and have the ability to make changes before getting boards back, I think that's really the first element that they should think about. And the next elements have to do with submit your products into our cloud scale interop lab, where we can help actually prove interoperability with a specific CPU or endpoint in order to prove that interoperability. And now that Micron's SSD is part of our cloud scale interop lab, we can provide end-to-end connectivity through our switches, through our retimers, through our gearboxes, which is a new device we didn't get to touch on too much, but through all of this PCI Express infrastructure, and that's also going to help our joint customers get to market.
So if someone's not engaged with Astera Labs, what should they do?
Reach out. We've got our Cloud Scale Interop Lab information right on our website. Reach out to us. We'll be able to hook you up with our team. We've got different interoperability sites around the world, both in Santa Clara and Taiwan. We actually really make it a point to bring this capability closer to customers so that we can, again, help them get to market as quickly as possible.
Cool. And anyone who's interested in a Gen 6 endpoint, we're sampling our SSDs already today. So reach out to your Micron contact, or if you don't have a Micron contact, then you can go on our website and there's a form you can fill out and we'll get back to you very quickly. So, Thad, thank you so much for coming today.
Been a pleasure, Jeremy. Thank you for the opportunity.
It's amazing to have you here. It's awesome to be able to be on the stage with you. Can't wait to have you back to talk about what's coming after Gen 6.
Okay. Very excited.
He'll be back. He'll be back.
You got it. All the best.
Thanks, Thad.